Okay, chapter 18, we're going to move from talking about Earth's surface to Earth's waters. So water on Earth, it's obviously important. It's a recurring theme we keep talking about, but water is the most abundant chemical compound near Earth's surface, covering approximately 70% of the surface, with 97% of it being in the oceans and being saltwater, and leaving us with only about 3% fresh water, meaning it still has some salt, but it's less than 0.05%, which is a small amount. 2/3 of our fresh water, though, however, is locked up in ice caps, so it means we have less than 1/3 of our fresh water available for all of the uses that we use it for. So the water cycle is the process in which water cycles through our world. So the water that was here today is the same water that was here when Jesus was around and before Jesus. It's just been recycled multiple times. So part of the process is evaporation from the ocean, forms clouds. The clouds move inland, and then rain, and the rain falls down onto the land, runs off into lakes and streams, then returns back into the ocean, which then all repeats the cycle. So precipitation is our basic freshwater source. 2/3 of the precipitation that falls evaporates back to the atmosphere, leaving us with 1/3 that will then run off downhill or be absorbed by groundwater, be absorbed as groundwater below the surface. So runoff or groundwater distribution, meaning how much runs off and how much is absorbed, depends on the soil type, the dryness of the area, amount and type of vegetation, and the steepness of the slopes and the rate of rainfall. So when we get lots of rain, it can't all be absorbed by the ground as quickly as it's falling, so it's going to flow into rivers. Dry creeks will fill up to help accommodate that extra rainfall. So these are all factors that will determine how the water is absorbed as either surface water or groundwater. So collectively, our surface water is stored in streams, ponds, lakes, and reservoirs. A watershed is going to be the land of, or a portion of land area that's going to drain into a stream or streams. So two adjacent watersheds are going to be separated by a divide. And then the continental divide separates watersheds draining into opposite sides of the continent. So, for example, you have the Columbia River watershed in the Pacific Northwest. So this obviously is related to the Columbia River. And then you have the Colorado River watershed that the Colorado runs through it. And then the Mississippi River watershed, which is a huge watershed here. Lots of rivers and streams are going to pour into the Mississippi, which then flows out into the Gulf of Mexico. Here in East Texas, we have several local watersheds that are small. We have the Caddo Lake one, Cypress Creek, Lake of the Pines. East Texas is full of water as opposed to some other places in the United States and even in Texas. However, there are small watersheds like our local ones, and then there are much larger watersheds like the one you see on the top image. Groundwater is water that has seeped down below the surface and is stored underground. It's going to find open spaces between rocks and soil particles, and then it's going to percolate downward from the surface. The groundwater supply is 25 times larger than that of the surface water supply. It tends to be cleaner than surface water. The problem is getting groundwater above surface, and that's done using wells. So normally these are artesian wells or maybe a water table well, but you have what's called aquifers, which are areas below ground where water is stored. And aquifers are really precious resources. Here in Texas, in the plains area like Lubbock, you have the Ogallala aquifer, which is a very large aquifer that feeds a lot of big places, but it's also kind of rural as well. And then in Austin area, you'll have what's called the Edwards aquifer. And these things are normally tried to be really well protected because they're kind of our last ditch resort for water. If we run through a period of drought where we just don't have the surface water we need, we can tap into the aquifers. But the thing is, these aquifers take a lot longer to fill up than what you would expect. So draining them completely dry poses a long-term problem, And so we try to reserve aquifer water for balancing it out and using surface water more. So in your groundwater deposits, you're going to have what's called a zone of saturation, which is a collected groundwater above an impermeable layer. So impermeable means it can't fall through. It's kind of like concrete. And so the water is going to be in this gray area in the top image of a saturated permeable layer. Normally this will be below things like lakes, rivers, swamps. The water table is going to be the top boundary of the zone of saturation. So this is where a lot of your like your household water wells are going to be. And then water can move laterally within the zone of saturation, meaning it can flow down and go into places like the ocean. An aquifer is a subsurface layer of highly permeable material capable of producing water. An artesian aquifer is confined under pressure from water at higher elevation. And so normally these are going to be artesian wells. And then there'll be an area of recharge where once water lands there, it's going to recharge the aquifer, which will then charge the wells. But again, aquifers are a little bit more precious resources than your surface water. So fresh water is required for all of life. The average U.S. usage is 570 liters, which is actually 150 gallons per person per day. Now 40% of this is agriculture, 40% is production of electricity, 10% is industrial, and only 10% is domestic. So even though they average 150 gallons, it doesn't mean that you are personally using 150 gallons. It's averaging all of these different ways we use it and then saying of this billions of people that live here, each person is using about this amount. So most of our water supply comes from surface water, which tends to have heavy sediments, bacteria, and pollutants. So there's a requirement to filter, treat, and process it. That's why we have wastewater treatment plants in cities, and they're responsible for testing. And that is normally, or co-ops are places where you will get water from. And then some people will opt not to have a public water supply, but will have a private water supply like a well. The thing about surface water is it's heavily dependent on precipitation. So if we go a long time without rainfall, then we're going to really struggle with clean surface water and the refilling of surface water. Over 40% of our water, fresh water, comes from groundwater, which is relatively free of bacteria and suspended particles. But it's more expensive because it has to be pumped to the surface, which takes energy, materials, supplies. And so normally fresh water is our go-to place for our domestic use of water. So we're going to stop here for chapter 18, just the first little bit, and we'll pick up with talking about seawater and a few other things about the ocean on the next